Allocating and optimizing RAM, CPU, and disk space in virtual machines. Virtual machines, VMs, rely on system resources like RAM, CPU, and disk space to function efficiently. Poor resource allocation can lead to slow performance, crashes, or excessive resource consumption, affecting both the virtual machine and the host system. Properly allocating and optimizing these resources ensures better speed, stability, and efficiency in your virtualized environment. Allocating and optimizing RAM for virtual machines. RAM, random access memory, determines how much temporary working memory a virtual machine has. The amount of RAM allocated affects speed, application performance, and VM stability. Recommended RAM allocation for VMs. Lightweight OS 1 GB to 2 GB. Standard usage 4 GB to 8 GB. Heavy applications 8 GB to 16 GB plus. Enterprise servers 16 GB to 64 GB plus. Best practices for RAM optimization. 1. Do not overcommit RAM. Keep at least 2 GB free for the host. 2. Enable memory ballooning. Allows dynamic borrowing or release of RAM. 3. Optimize VM background services. Disable unnecessary background processes. 4. Use RAM-efficient operating systems. Choose lightweight Linux distributions for multiple VMs. Allocating and optimizing CPU for virtual machines. The CPU determines how fast the virtual machine processes tasks. Unlike RAM, CPU resources are shared between the host and VMs. Recommended CPU allocation. Basic task 1 vCPU. Software development 2 vCPUs. Graphic design and video editing 4 vCPUs. Enterprise applications 6 to 8 vCPUs or more. Best practices for CPU optimization. 1. Avoid over-allocating CPU cores. Never allocate more than 75% of total CPU cores to a single VM. 2. Enable virtualization extensions. VTX AMDV improves virtualization efficiency. 3. Adjust CPU priority in hypervisor settings. Set high priority for critical applications. 4. Enable nested paging in PANX. Reduces CPU overhead. Allocating and optimizing disk space for virtual machines. Disk space is where the virtual machine stores its operating system, applications, and files. Unlike RAM and CPU, disk allocation cannot be dynamically changed in most hypervisors once the VM is created. Recommended disk space allocation. Lightweight OS 10 GB to 20 GB. Standard usage 40 GB to 100 GB. Large file storage 100 GB to 500 GB plus. Enterprise servers 500 GB to multiple TBs. Best practices for disk optimization. 1. Use SSD storage instead of HDD. SSDs dramatically improve VM performance. 2. Enable trim for SSDs. Prevents performance degradation. 3. Store virtual disk files on a separate drive. Prevents resource conflicts. 4. Compact and defragment virtual disks. Prevents fragmentation. Common resource allocation mistakes to avoid. 1. Over-allocating RAM or CPU to a single VM. 2. Forgetting to enable virtualization in BIOS. Using HDDs instead of SSDs. 4. Ignoring VM disk cleanup. 5. Allocating too little RAM or CPU. Final thoughts. Mastering VM resource management. Allocating the right amount of RAM, CPU, and disk space is crucial to getting the best performance from your virtual machines. While assigning more resources seems beneficial, it is important to strike a balance between the host system and VM needs. By following best practices such as avoiding resource overcommitment, using SSDs, enabling virtualization extensions, and optimizing hypervisor settings, you can ensure smooth, fast, and stable VM performance.